Is this triangle right angled? We cannot say for sure because we do not have the box in the corner to indicate a right angle. Without that box there, we cannot make a claim as to whether or not the triangle is right angled. In Pythagoras' theorem in a right angled triangle, we were told that c squared is equal to a squared plus b squared. The hypotenuse squared is equal to the sum of the squares of the other two sides. So essentially what we can say here is that if the hypotenuse squared is the same as the sum of the squares of the other two sides, then the triangle is right angled. What we're going to look at in this video is the converse of Pythagoras. So the converse would state that if the triangle is right angled, then c squared equals a squared plus b squared. The converse of that statement is that if c squared equals a squared plus b squared, then the triangle is right angled. We're going to look at that with a few examples. Let's look at this example here. We've got a triangle. Let's call the triangle ABC. And we want to figure out whether or not this triangle is right angled. We don't have a box there to tell us. But we can think about the converse of Pythagoras. We know that if c squared is equal to a squared plus b squared, then it has to be right angled. So what we're going to do is we're going to look at the longest side. I'm just going to call it LS for short. So the longest side is this 20. So this would be like our usual C. So what we're going to do is we're going to do 20 squared. I'll write that in red. 20 squared, which is 400. That is essentially C squared. We're going to look at our shorter sides. Just write that out. And we're going to add those two sides together squared. So we're going to do 10 squared plus 16 squared. 10 squared plus 16 squared. Well, 10 squared is 100. And if I'm adding on 16 squared, I'm going to get to 356. Is this triangle right angled? No, because this value here is not the same as this value here. If these values were the same, it is right angled, but because it's not, I cannot say that this is right angled. It is not right angled. With the converse of Pythagoras sort of problems, you need to finish your answer with a conclusion. How I would write my conclusion is I would say that since 10 squared plus 16 squared does not equal 20 squared, then by the converse of Pythagoras, this triangle is not right angled. Okay, so in your conclusion, you need to mention your calculation. You need to mention whether or not it is equal or unequal, and if it is right angled or not. And you need to mention the phrase by the converse of Pythagoras. We're going to look at one more example. Okay, let's look at this example here. Is this following triangle right angled? We can't tell because we don't have a box here. So what we're going to do is we're going to look at our longest side and we're going to square it because that would be C normally. Okay, so what we're going to do is we're going to look at our longest side. To do that we would do C squared. So we're going to do 26 squared. 26 squared is 676. We're going to look at our shorter sides. We're going to add together 10 squared and 24 squared. If we do that calculation, 10 squared plus 24 squared, we're going to get the answer 676. We need to compare these numbers. If they are the same, then our triangle is right angled. Yes, it is right angled. I can put my box in. This triangle is right angled. So to finish off a Converse of Pythagoras question, you need to finish it with a conclusion, you need to finish it with a statement, and here our statement would say, since 10 squared plus 24 squared, since 10 squared plus 24 squared is equal to 26 squared, then by the converse of Pythagoras, this triangle is right angled. So I need to mention 10 squared plus 24 squared being equal to 26 squared, and then by the converse of the Pythagoras, this triangle is right angled. Okay, so those are your two examples for the converse of Pythagoras, which allows you to determine whether or not our triangle is right angled or not. Thank you very much.